Hello, this is Professor Cedarberg, and we're going to be talking about arrays. Now, arrays are defined as collections of items of the same type. An array always holds things of the same type. Now, that type might be one of the primitives, it might be instances of a class, but all of the items in an array have to be of the same type. Now, an array has a size, and that size is fixed at the time of the creation of the array. That size can't change, can't get bigger, can't get smaller. Now, the positions in an array are assigned numbers, indexes. And so we have these index numbers begin at 0. Just as with a string we have the first character is at position 0, the same with an array. The first thing in an array is at position 0. Now, arrays have an instance variable. That instance variable is length. That instance variable is an int, and it indicates the size, the number of items that can be held in that array. Now, strings have a method length. Arrays have an instance variable. So we find the length of an array with the name of the array dot length, and that'll return back an int, the size of the array. Remember, since we index starting at 0, the last position in an array will be length minus 1. When we work with arrays, we have to first declare that we want to have one. And so we can declare an array this way. We indicate the type. The square brackets that follow that type indicate that this is indeed an array of that type, and then the name of the array and the semicolon. We can also declare an array this way with the type, the array name, the square brackets, and a semicolon. The first way, type, square brackets, array name, is preferred. The second way, type, array name, square brackets, is okay, but the first is the preferred way. So having declared that we want to have an array, now we have to actually create it. And so we create it by indicating the name of the array, and we have previously declared it, the assignment operator, the keyword new, we repeat the type, and then in square brackets, the size, the number of items that we want held in this array, and then a semicolon. So we create an array with the array name, the assignment operator, the keyword new, the type, a repetition of the type, and then the size, and that size is in square brackets. So we have a namespace, we create the actual array, and we assign that newly created array to that namespace. Well, actually what goes into the namespace is the address of the first space in our newly created array. So in the namespace is an address. So here, as an example, I've declared an array of ints I'll call array name. Here I actually create that array with array name, the assignment operator, the keyword new, a repetition of the type, that's an int, and here I've created an int of size 6. So here's my declaration, here's my actual creation. Now I can declare and create on one line. Here I declare and create an array of booleans of size 6. Here I declare and create an array of shorts of size 12. Here I declare an int a, give it a value of 10. In the next line I declare and create an array of doubles of size a. So you can see that I can indicate the size of the array with a specific number being passed in, as with 6, or the result of a calculation, 4 times 3, or the name of a variable that holds a value, as I have with a. Now, when working with arrays, we have to remember that the address of the first element of the array is what's stored in the namespace. So that namespace, the name of the array, holds an address. And so here I declare an array of ints of size 6. I name it my array. The namespace my array points to the first element, the first element in my array. Now this array is of ints and it's size 6, so I've put aside, or memory's been put aside, 24 bytes, 4 bytes for each one of those 6 ints. Now I can assign values to the spaces in my array. I had previously declared and created my array, and it's of size 6, so here I've assigned values to each one of the spaces of that array, spaces 0 through 5, and I've given the values 2 through 12. And so in memory, I now have those values stored in those spaces. It's very common to use a for loop to assign values to an array. So here I've declared an int called sum. I gave it a value of 1. And here's a for loop. And a for loop's perfect for this because I know how many times I have to iterate through. The number of times I'm going to iterate through will be the number of items that I have in the loop, in the array. So my loop wants to go execute that number of times. So here's my for loop. I have an int I, give it a value of 0. I say as long as I is less than myArray.length, and I've previously declared and created my array. As long as that's true, I'll go into this loop and continue through this loop, and each time I execute this loop, I'll increment I. So going into this loop the first time, now we've got my array has been given a value of 6. So I've got this sum, give it a value of 1. I'm going to go into my loop. I'll have I is given a value of 0. I'll test, is I less than myArray.length? Yes, it is. I go into my loop. I find the value of sum. I multiply it times 2. Sum is a value of 1. Multiply it times 2, put it into sum. So sum now holds a value of 2. I then find the value of sum, put it into my array sub I. And that's how we say that, sub I, at position I. And I is a value of 0, so into position 0 will go the value 2. I increment I, come back up to the top of my loop, I do my test, I is indeed less than myArray.length. I go into my loop and I go through this loop 6 times. And after this loop is finished, I have these values stored in the spaces of my array, 2, 4, 6, 8, 10, and 12. Now I can declare and assign values to an array using this shortcut. With here, this example, I've declared that I will have an array of type int called another array, and I've established its size as 4 and put these values into those spaces, 3, 6, 9, and 12. This declares, creates, and assigns values all on one line. And I can do this if I know the specific values that I want to put into my spaces. Right? I'm explicit on the type. I indicate it has to be ints. But I'm implicit on the size because my size is determined by the number of things that I passed in. So here my size is 4 because I passed in that number of items. So this is a shortcut way to declare, assign, create all in one fell swoop. And after that's through executing, here I've got memory space, and in position 0, 1, 2, and 3 I've got 3, 6, 9, and 12, and that's of the array another array. Now if I want to access values, right, I'm going to do that. Now let's assume that I have an array of size 4, the array we've been working with, and it's got 3, 6, 9, and 12 in it. If I want to access any one of those spaces, well, I'm going to create an int called A. Let's just create that. And into A, I'm going to put what's in position 3 of my array another array. And so I'll have the line A equals another array sub 3. Right? A therefore has the value of 12 stored to it because I've taken the value 12 from position 3 and put it into that space A. Now remember, my memory always has enough space to hold the items that are of the type declared. So here I've declared my array of type int, its size 6, that's what I have in memory, 24 bytes. The length of my array, remember, is an instance variable, right? And the instance variable is called length. It's the number of elements in an array, and the last element is always length minus 1. So if I were to work with this array of 6 elements, and I declared my array int my array equals new int 6. I've made an array of size 6. My array.length will return 6. My array.length minus 1 is the last position. That's position 5. It's very common when working with arrays to be off by 1, to be looking for what's in position length. There's no position length. In this example, if I were to look for position 6, I'll get an array out of bounds exception. You can't look for something in a space that doesn't exist. So when we work with memory, here we'll have an array called this array. It's of type int, and it's of size 6. So with that line, I've put aside some memory. Now I'm going to declare another array called that array, and it's of size 5, and it holds ints. So some memory is put aside for that. Well, now what I'd like to do is execute this line. That array, the value stored in that array is stored into the space this array. Well, we know that that array is an array of size 5. We know that this array is an array of size 6, but what's in the spaces this array and that array are memory spaces. So this array right now points to a specific memory space. That array points to another memory space. If I execute the line that assigns the value in that array to the space this array, what will happen is this, that I will have the value in this array will now point to the space that is that array. And the original space this array is orphaned. There's no mechanism to get there because nothing points to it. So here I have this array and that array pointing to the same space, which is the original that array. This array has been orphaned. Now we see that this array and that array are of different size. But that doesn't matter because what's in the spaces this array and that array are memory spaces. Right? It's an address. Right? It's just an address. So with the execution of this array equals that array, that is, I'm assigning the value in that array into this array, I take the address in that array and put it into the space this array. So now both of those point to the same space, which is the original that array. Now, there is a class that comes with the Java language that's very, very useful when dealing with arrays, and it's the arrays class. It has a number of methods. These methods are static, and here's the more popular of them. Most of these are overloaded. I encourage you to go and look at the methods binary search, copy of, equals, fill, sort. You will use them a lot as you work with and manipulate arrays. They're tools that are there for you to use. So let's conclude. As we look at arrays, we define them as a collection of like types. Right? We declare that we'll have an array. We create the array that is put aside memory space sufficient to hold the number of items of the specified type. Memory is put aside, and in the namespace of our array is stored the address of the first item in our array. We have an arrays class that provides us with a number of methods that we can use as we manipulate arrays. We can create our own methods as we need, but we have these to help us. So here we've looked at arrays. They are very, very useful in programming. You will use them a lot. Thank you very much.